Alright, Reality Desire Part 2, we're going to talk about how you deal with bad components and how you deal with specific different types of bad components.
Here we have two different components, the orange component and the blue component. The orange component is composed of only one cycle, and the blue component is composed of two different cycles, but because they intersect, it just makes blue one component. So we need to figure out if these components are good or bad, so to do that we apply our orientation. Here's the orientation of blue, and here's the orientation to orange. And now we check by applying an orientation to the outside of the circle to see if there are any diverging edges. And up here in orange we have a diverging edge, so that means that orange is a good component. Blue doesn't have any diverging edges, so that makes blue a bad component.
So, bad components, there are a few different types. We have non-hurdles, and non-hurdles separate bad components from one another. Hurdles do not separate bad components from one another, and a hurdle can be a super hurdle or a simple hurdle. And to be a super hurdle, the hurdle protects a non-hurdle. So if we take that super hurdle out, our non-hurdle is now a hurdle. And a simple hurdle does not protect a non-hurdle. So let's look at an example. Here we have a few different types. So F is a super hurdle. It is protecting E, which is a non-hurdle. If we remove F, E no longer separates F from A or F from B. So E doesn't separate a bad component from anything else without F, and it would become a hurdle. A, D, and C are all simple hurdles, and E and B are both non-hurdles. You can see that A, D, and C are simple hurdles because if you removed any one of them, it wouldn't change anything else. So let's see what happens when we remove F. With F gone, E is now a simple hurdle. It's not separating any bad components from one another. D, C, and A are all still simple hurdles, and B is still a non-hurdle. Now if we remove A, E is now a super hurdle because E is protecting B. B is separating E from D and C, and if we remove E, B no longer separates bad components. So how do we deal with these bad components? Well, depends on if we have an even number of bad components or an odd number of bad components, or if we have a fortress. So we're going to talk about an even number of bad components first. Here we can see that we have two different components, and after examining our orientation, we have no divergence, so we have two bad components. With an even number of hurdles, we can do a hurdle merging. And the way a hurdle merging works is you pick the reality edges from two different hurdles and you perform a reversal on those. So a hurdle merge will always decrease the number of hurdles by 2. So if you have an even number of hurdles, it's always going to be more efficient to be performing hurdle mergings than your other options. So let's look at this. We have 4 hurdles here, F, A, D, and C. So the first thing we would do with our even number of hurdles is enumerate them. 1, 2, 3, 4. And now you want to pick 2 opposing hurdles to perform the hurdle merging on. So F and C are opposing, and A and D are opposing. So you'd pick the reality edges, one reality edge from F, one reality edge from C, and perform a reversal on those two to get your hurdle merging. Let's look at this in our example. We have 2 different hurdles here. One is blue, one is orange, so let's enumerate them. 1, 2, they obviously oppose each other, so now we can just select 2 reality edges, one from each, and perform the reversal there. So there they go, they're reversed. Now we draw back in our desire edges, check our orientation, you can see here that we have 3 different cycles, but because they overlap, it's just one component. The purple arrows come in to show us if we have any divergence, and yes we do. We have 2 points of divergence, so we have a good cycle, so a good component. We're going to pick one of these 2 edges to perform our reversal with. So we pick this edge here and this edge down here, and we perform our reversal. And now we draw back in all of our desire edges, do our orientation again, and then we're going to check for divergence. And now the orange cycle has divergence where the blue and black do not. So we have a good cycle and a good component. Pick that edge and that one up there to perform a reversal. Draw back in our desire edges. The orientations go on. Do we have divergence? Yes. Select this edge here and this edge over here and perform our reversal. Draw back in our desire edges. Check our orientation and divergence. Yep, divergence. Black cycle is a good cycle, making everything a good component. Pick this edge here and this edge here to perform a reversal. Desire edges come back in. Orientation, divergence is still there. Perform a reversal on this edge and this edge. Desire edges come back in. And we are sorted. You can look around the circle and see that everything is in sorted order. So what if we have an odd number of components, bad components? Well, here we have one component. Is it bad? Yes, it is. So how are we going to deal with it? We are going to do some hurdle cutting. With hurdle cutting, which is a reversal within a hurdle. So we're going to pick two edges in the same cycle in the hurdle, there and there, and we're going to perform a reversal on those two edges. Okay, reversal's done. Let's draw back in our desire edges, apply our orientations, and see if we have divergence. Yes, we do. So now we have a good component, and we can treat it like we do the good components, pick those diverging edges, and perform reversals. There's our reversal. Edges come back in for the desired edges. Orientation is applied. Check for divergence. Yes, there's divergence. We're going to perform a reversal on those two edges. We perform the reversal. Now we're going to draw in our desired edges. Everything is paired off into a pair with one reality and one desire edge. And if we look around the circle, again, they're sorted. So that's how you deal with an even number, or with an odd number of hurdles with hurdle cutting. Now we're going to look at the third case.
The final case to deal with is the fortress. Now, a fortress has an odd number of hurdles, and all of the hurdles in the fortress are super hurdles. So here we have 3 hurdles, 1, 2, 3, and each one of them is a super hurdle, making this a fortress. So how do we get started in sorting our fortress? Well, we pick any 2 hurdles, pick one reality edge from each hurdle, and perform the reversal on those 2 reality edges. So just a hurdle merging from any 2 hurdles inside the fortress. Once you've done that first move, you're going to be in the position where you'll have a good component, or an even number of hurdles, or an odd number of hurdles, but one of them will be simple. And then you can just use what we've already done before and keep going through to solve the sorting of the fortress. So now that we've covered bad components as well as the fortress, we can now come up with a more accurate estimation as to what our minimum reversal will be.
So the reversal distances, we can get a more accurate number for a reversal distance with this formula, where C of alpha is the same, N is the same, but H of alpha and F of alpha are added in, where H of alpha is the number of hurdles, and F of alpha is 1 if it is a fortress, and 0 if it is not a fortress. So here's our algorithm. We have 2 permutations. A is our unsorted permutation and B is our target. We make our reality desire diagram for A, pick two divergent edges in the same cycle of A. Make sure that the reversal is a sorting reversal and doesn't create a bad component. If it does, we roll back and do a new reversal. If it doesn't, we continue because we have a good cycle and a good component. If we have hurdles and an even number, we do our hurdle merging and then go back through the same process. If it's odd and it's a simple hurdle, if it's odd and we have a simple hurdle, we do a reversal cutting, a hurdle cutting. And if we have a fortress, we just perform that merge. And then in every case, when we deal with the hurdles, we're back up to the top and seeing if we have a good component. So that's how you go about dealing with the reality desire diagrams. Our information came from this book here. Thanks.